Hi everyone, welcome back. We're going to be working on 9.5 counting principles today. The essential question is, how do I solve large-scale counting problems? So our focus today is going to be on several types of problems where there's going to be a lot of counting involved, but we don't want to really count anything that goes beyond, 20 possibilities. And we're going to learn some formulas to help us figure out those types of problems. So the first one I want to look at, but not have you guys write down, is this example from the book. So this situation says that a bunch of pieces of paper numbered from 1 to 8 are put in a box and also put back into the box after you draw it out. You're supposed to get a sum of 12, and they're asking us how many ways could that happen. So based on a couple of arithmetic deductions, we figure out that only these slips of paper would help. And by counting, literally listing and counting the possibilities, we find out that there's only 5 ways that a sum of 12 could happen. So this is the basic idea of a counting problem, but in the problems that we're going to be doing in our examples, we're going to see a much larger scale type problems because not everything works out so nice and small like this one. So the first thing I want you guys to write down is the fundamental counting principle, and it's actually defined right here. So go ahead, copy down that yellow highlighted text. And basically the fundamental counting principle lets us use multiplication in order for us to count the number of possibilities of something that's going to happen. Okay? So go ahead, write that down, and we're going to go ahead and move into the first example. The first example that we're going to have is the question, how many different pairs of letters from the English alphabet, gotta be specific, are possible? So in this situation, we could, I repeat, could list out every single thing, but that's going to be a waste of paper and a waste of your time. Because what's being asked here is that all of these combinations, AB, AC, AD, AE, and I'm pretty sure you get the picture, all the way down to ZZ. Okay, actually AA is also possible. All the way down to ZZ, and we need to count how many possibilities there are. Now, for those of you crazy enough, you would list it all out, but for those of you who want to take advantage of some counting principles, we're going to do something that's very simple. We know that we need a 2-digit or 2-letter item. All of my possible choices include A, B, C, all the way down, all the way to all 26 letters. Over here, because we're not being specific about whether or not it can repeat, we'll assume that we can go through A, B, C, all the way down to the rest of the 26 letters. In other words, here, I have 26 letters to choose from. Here, I also have 26 letters to choose from. In order to count the number of possible pairs of letters using all of the letters from the English alphabet, the fundamental counting principle lets me multiply the number of possible letters for each slot to give me my answer. In this case, 26 times 26 will give me 676. So, there are 676 potential pairs of letters in the English alphabet. Okay, so that's example 1, using the fundamental counting principle. Example 2, we're going to change it up a little bit to show that it's not always going to be the same number. So everyone knows that phone numbers are made up of 10 digits. So a 10-digit phone number. And our question is, how many numbers are possible within the 714 area code. Okay, so we're going to focus only on the 714 area code, because if I were to include all other possible area codes, that's going to be a huge number. So let's be a little specific here. So first off, my 10-digit phone number is made up of 714. Then I'm going to have 3 digits for that first part, and then 4 digits for the remaining. Now, the one thing you do have to know and kind of bring in the real-life experience here is that I can't use 0 or 1 in this first spot. Okay? Now, that's something that either you're going to have to memorize or they're going to have to tell you, but 0 and 1 cannot be used in this spot. On the other hand, the numbers 2 through 9 are potential candidates. So in this case, I have 8 numbers to choose from. Okay? So 2, 3, 4, 5, 6, 7, 8, 9 can all be the first digit there. And then the rest of the numbers can be any digit between 0 to 10. So in this case, I'm going to have 10 choices, 10 choices, 10, 10, 10, 10. All right? So based on that knowledge, we're going to be able to count how many phone numbers there are in this entire area. So, excluding the 714 because we're focused only on this area code, I'm going to take these 8 numbers and multiply it with everything else. So I have 8 numbers there, 2 through 9. And then 10 times 10 times 10 times 10 times 10 times 10. So in the 714 Orange County area alone, we have 8, 0, 0, 0, 0, 0, 0. 8 million possible phone numbers alone in the 714 area code. Okay? Now, if you were crazy enough, you would list them out. You would have 714. 663 1004. That's one possibility. Then you have 714 663 1003. And you get the idea. And that's only one section of it. If we were to go on forever and ever, we would have 8 million phone numbers. Not a fun thing to list out. Thus the need for the counting principle. Right? So we're going to go ahead and move on from the fundamental counting principle to the idea of permutations. Now, permutations and combinations all have their own specific formula, and we're going to go ahead, write down the definition of a permutation. So, permutation of n different elements is an ordering of the elements, such that one element is first, one is second, one is third, and so on. So, permutations are kind of based off of the idea of the fundamental counting principle, but we're talking more so about the order. And one thing I want you guys to make a really big note of is that in permutations, order matters. What do we mean by that? We will see in just a moment. So order matters. All right, so with our first example, example 3. I want the permutation, or the ordering, of 4 letters. And the letters I'll use, keep it simple, A, B, C, and D. So with this, one possibility is A, B, C, D. Another one, A, B, D, C, or D, C, sorry. Another choice, A, C, B, D, A, C, D, B, and so on and so forth, and it's going to be a lot. So rather than having to do all that, I'm going to use a permutation. And the way we do a permutation is that we think about each spot, we consider, okay, I know I want 4 letters, and I want them organized in whatever way possible. For the first slot, I can choose from 4 letters. In the second slot, if I already chose A, I can only choose B, C, or D. So I have 3 choices there. Same thing is, if I chose B first, then I only have A, C, or D. And then it just goes down from there. And what we have is basically 4 factorial. Or 4 times 3 times 2 times 1. That will give me 24. Not such a bad one to list out, but still it's a lot easier just to go about it this way. Okay. Example 4, I'm going to continue with permutations. And in this one, we're going to look at 10 swimmers who are racing. And our question is going to be, how many different ways can first, second, and third be decided? So if I had like swimmer A, B, C, D, all the way to the 10th letter, we would have to figure out in what way could we organize it. In this one, the formula we would need is the permutation of elements, or n elements, the total amount of people, taken R at a time. In other words, we have a total number of people that are involved, or terms, anything, and then we're only going to look at a certain specific set of them. Earlier, we only had 4 letters, and we were using all 4 letters. Here we have 10 swimmers, but we only want the first 3 places. So we're going to be using NPR, and that's the formula right there that we're going to apply. So in this case, N is equal to 10, and R is equal to 3, because we only have first, second, and third place. So NPR is going to be 10P3, written out, that will be 10 factorial over 10 minus 3 factorial. That's 10 factorial over 7 factorial. And just like from the last section, we learned that we can go ahead and cancel some things out. 10 factorial is the same thing as 10 times 9 times 8 times 7 factorial. Here we have 7 factorial, and those just cancel out nicely. So the total number of first, second, third place possibilities with these 10 swimmers is 720. Okay? So again, listing out all of those possibilities would not be fun, and thus the need for that. Alright, because this video is closing in at 13 minutes, I do need to stop it right here. But you will be continuing on to finish this section, so we're going to have a second video. Please go ahead and move on to that video now. Alright.